from roads to walkways and to every corner of your home. Cement is everywhere. Imagine how much cement we have produced to build skyscrapers and megacities. The word cement comes from the Latin word cementum, and it means a building material. Different types of binding materials have been used at different times. William Aspdin, a British mason, invented the modern Portland cement in 1824. He called his invention Portland cement because of its resemblance to Portland stone. This cement has brought a construction revolution to the world and helped builders build unbelievable megastructures. We can give it any shape. It binds the most essential construction material, and once solidified, it holds them together for years. Let's delve into its manufacturing process. But before that, make sure to subscribe to this channel. Cement production requires 80% raw limestone. Luckily, the earth has plenty of it. Its mining starts with a bang. By breaking limestone rocks, it makes this job easier for everyone. Controlled explosions take place 100 times a year, and each blast produces nearly 2,000 tons of limestone. Let's have a closer look. First of all, a drill machine makes holes to a certain depth. Then, a team of explosive experts binds a cord with a sausage-shaped cartridge and lowers it into the bottom of the hole. Next, a few more cartridges are put into the hole. The hole is filled with freely flowing ammonium nitrate, approximately to a depth of 1.5 meters. Another cartridge is lowered into the hole with a detonator. Lastly, the hole is filled with gravel. In this way, multiple holes are prepared for blasting, and their cords are connected on the surface. Before blasting, they make sure that no one is around the blasting area. It's time to blast the limestone. Excavators and wheel loaders can now easily load the limestone onto dumpers, and the dumpers transport it to the crushing plant. During operations, the wheels of these dumpers face wear and tear. For just one dump truck, the cost of a wheel could be up to $20,000. Each dump truck itself costs around $100,000 US. The dumper unloads the limestone straight into the crusher plant. There, 3 crushers are connected in a row. They crush the limestone 3 times, which reduces it from 1 meter of rock to only 20 millimeters of pebbles. The crushed material goes to the stone storage. Likewise, shales and other essential materials are also stored. Interestingly, shale does not need blasting and can be easily excavated using heavy-duty excavators. These primary raw materials are further grounded to a fine powder before they are mixed together. Usually the mixture contains 80% limestone and 20% shale. These mills contain steel balls, which, upon continuous rotations, evenly mix up all the raw material and transform into the required powder size. It is called the raw meal, which goes to the several-story tall silo. The raw meal moves from the top cyclone to the bottom, and it heats up from 80 to 830 degrees Celsius in a few seconds. After that, it goes to cement kilns. You can see 2 cement kilns here. Both of them are 70 meters long and 4.8 meters in diameter. Each kiln completes 2 revolutions in a minute, and giant electric motors and rollers are used to make them rotate. It cooks the raw meal at a temperature of 1,500 degrees Celsius. Coal is mostly used to achieve such high temperatures. Nowadays, many cement manufacturers also use processed waste material for combustion. This high temperature allows the limestone and fly ash to combine chemically. It results in a new substance called clinker. The clinkers are then cooled down rapidly from 1,400 degrees Celsius to 150 degrees Celsius. It can be stored in silos for months, and cement can be made from it at any time. From the silo, clinkers enter the cement mills for cement production, where additional additives are added. For instance, 3 to 4% gypsum is added to Portland cement, to prevent it from setting too quickly. These cement mills produce one batch of the cement after the other. Workers in the control room monitors each and every process of the cement manufacturing and make sure it meets certain standards. Besides that, samples from each cement batch are taken to the lab. In the lab, more than 11 sampling tests are conducted. The cement is tested for its compressive strength, water demand, finesse, and expansion. The final cement is either packed in cement bags or poured into the container. Each cement bag contains 50 kilograms of cement. Robotic machines count and stack these bags on a pallet. Each pallet generally has 40 bags. The bags are then wrapped with plastic for additional protection. This packaging plant of Ohorongo Cement, a cement company in Namibia, can handle up to 4,000 cement bags every hour. In construction, cement is used almost everywhere, between bricks as a mortar, on the wall as a plaster, and everything that is made of concrete. This includes floors, roofs, wall blocks, walkways, piles. The list goes on and on. It pertains not just to a single building, but to nearly every building on the planet. Perhaps this is the reason the world produces 4.1 billion tons of cement every year. China is the largest cement producer, producing 2.13 billion tons cement in a year. Surprisingly, it is more than half of the total global cement production. India ranks second, producing only 410 million metric tons per year. Although cement can be used in many ways, most of it is used to make the world's most used material after water, concrete. Compared to 4.1 billion tons of cement, the world produces 30 billion ton concrete in a year. Typically, concrete is made by mixing 10 to 15% cement, 15 to 20% water, and 65 to 75% aggregates. Often, cement is transported from one factory to another by trains and trucks. There they produce precast concrete blocks. First, the design plan is analyzed to make blocks of the desired size. Next, workers and machines prepare the required rebars based on the length of each precast concrete block. This process entails the cutting, bending, and tying of rebars together. Rebar wheelchairs are used to help position the cage and to ensure proper clearance of reinforcing. A variety of steel forms are used for the formation of precast concrete. All the cut opening cutouts are secured to ensure that the final product can be easily lifted from the forum. An overhead crane is used to pick and place the cage onto the core. Once setup is complete, a quality control technician conducts pre-pour tests to ensure the best quality. After his approval, cement, coarse aggregate, and chemical admixture are mixed together to make concrete for the precast. Companies also have raw material laboratories to analyze the characteristics of these materials, such as compression strength and spread tests. From the approved batch of raw material, concrete is made and poured into the production form. During this, it is made sure that concrete floats without any air void. After uniform filling, the top of the form is screeded off, and the specified finish is applied. The next step is curing. The forms are covered with a tarp to capture heat from the hydration process. After that, a quality control technician evaluates the curing, and if it has reached the desired strength, the stripping process begins. This process encompasses all the steps involved in separating the product from the form. Then, this new precast concrete is inspected for the last time. The finished product goes to the yard and from there to the construction site. Many companies have automated machines capable of producing concrete precast at a massive scale. There are many advantages to using precast concrete. They are customized according to building infrastructure. Quality can be better ensured in precast factories than building something on the construction site. But one important advantage of using precast concrete blocks is a reduction in construction time. Look at this building. It took only 28 hours to complete its construction. The use of precast blocks eliminates the need for building walls and roofs entirely. A precast is just joined with another to complete the structure. It demands less labor, less cost, and less time. During COVID-19, news broke out that China built a large hospital facility in Wuhan in an unprecedented time frame. The Huashinshan Hospital was built in just 10 days. It was equipped with 1,000 beds, including 30 intensive care units. China employed around 7,000 workers, including plumbers, electricians, etc. They were able to do it because of precast technology. Some companies are even constructing entire structures using just a few precast units. Broad Homes Global is one of them. With their precast home, they can construct a ready-to-live house in just one day. They prepare the precast structure and complete its finishing in the factory. These units are brought to the construction by heavy-duty trucks and trailers. Then, the builder assembles these units one after another. 3D printing technology offers a whole new way to use cement for building infrastructure. We have covered this topic in our brick manufacturing video. But cement is not used only for raising buildings. Our long highways, roads, and even streets contain plenty of cement. Roads are often composed of asphalt containing bitumen as a binding material. But sidewalks, highway barriers, and other structures need a significant amount of cement. Concrete roads are also preferred for highway construction since they have longer life than typical asphalt roads. But no matter which way cement is used in the construction, there is a problem with it. The production process of cement emits a significant amount of CO2 and other greenhouse gases. In fact, out of the total global emissions, cement manufacturing accounts for 8% carbon emissions. One way to cope with this problem is to use cement alternatives. Limestone has been used as a mortar in the construction of ancient buildings, such as Fremantle's heritage buildings, and some historic churches and cathedrals. In many poor countries, clay is still used to build houses, but these materials do not offer enough strength to build complex infrastructure. However, mixing lime with the woody part of hemp plants results in hempcrete. In recent years, it emerged as a sustainable solution and can largely reduce the use of cement. It can be used to manufacture building blocks. Lime mortar and lime plaster are used instead of cement. The hempcrete is lightweight, heat-resistant, and eco-friendly, and it offers load-bearing characteristics. Recently, its use got traction. You may have seen workers building walls with hemp blocks, pouring into the floor, and much more. For road construction, recycled plastic waste can be used. In this way, we can not just replace asphalt cement, but also help reduce the overwhelming amount of plastic waste. According to some reports, over 33,700 kilometers of recycled plastic-bound roads have been built in India. To reuse plastic, high-density polythene and low-density polythene plastic are sorted. Next, the material is cleaned and dried before shredding. It is then melted at 160 degrees Celsius, and the melted plastic is mixed with bitumen, which increases the melting point of the mixture. This will help the recycled plastic to maintain its flexibility during winters. There is another building material that we have been using for thousands of years: wood. But since 2018, a resurgence in its use has been noticed, and the reason is mass timber. It includes various engineered wood products, such as glue laminate timber and cross-laminated timber. Glue laminated is created by gluing and compressing together layers of wood, typically with the grains aligned in parallel. This process enhances its strength, durability, and flexibility, making it suitable for long-span structures and roof beams and trusses. We have covered in our balsa wood video how a company is using it to build wind turbine towers. Typically, these towers are made from steel, but the process of laminating multiple layers of wood and curving it gives this engineered wood equal strength to the steel tower. For making cross-laminated timber, each layer is oriented perpendicular to the adjacent layers. This enhances the structural rigidity and strength of the panel in multiple directions, making it suitable for multi-story buildings and residential homes. Here, mass timber is going through a shaking test, which will determine whether it is able to cope with earthquakes or not. In one way or another, these alternatives indeed demonstrate superiority over cement, but they also come with some disadvantages. For instance, more wood in the construction of buildings simply means more trees need to be cut down. Forests are already depleting at a rapid pace, and authorities cannot allow timber harvesting beyond a certain amount. The recycled plastic in road construction often melts down due to rises in temperatures. It not only results in premature road fractures, but also the melted microplastic pollutes the nearby soil and water bodies. Likewise, hempcrete has its own problem. It decomposes in the soil. Therefore, extra materials are used first to make it appropriate for the hempcrete, which makes hemp unsuitable for the construction beneath soil. All these disadvantages clearly imply that cement is the most versatile binding material in construction. Is there any way we can reduce its carbon emissions? The answer is yes. As we mentioned before, many cement manufacturers use coal as a fuel to produce clinker. Changing the fuel source can significantly reduce emissions. If manufacturers use an electrical heater in this process, out of 100, around 7% of the emission can be prevented. However, reaching temperatures more than 1450 degrees Celsius with electrical heaters is a challenge in itself. Companies such as Cymex and Coolbrook are in collaboration to develop this technology. We can reduce 26% of carbon emissions by reducing concrete use in buildings as much as possible. Using bubble decks in roof construction is one way to achieve this. These hollow spheres are made from recycled plastic balls to fill the gap. The plastic spheres are strategically placed within a framework of welded reinforcing mesh, which stabilizes the structure and maintains the necessary geometry for effective load distribution. Heidelberg Materials adopted another way to curb carbon emissions from their cement plant, and they succeeded in reducing 45% of it. So far, it is the only cement plant equipped with carbon capture technology. Instead of venting the CO2 into the air, it gets captured in the carbon storage. It is then transferred to another facility via pipes, which compresses it into fluid. The resultant fluid CO2 can be stored underground. This cement factory prevents carbon emissions equal to what 200,000 cars emit in a year. A startup based in the USA has developed a novel approach to CO2-free cement manufacturing. Biomason uses recycled aggregate as a raw material. Then, they introduce a specific strain of natural bacteria to the recycled aggregates. This bacterium mimics the natural processes seen in marine organisms that produce calcium carbonate structures, like coral reefs and shells. A nutrient-rich solution is added for the bacteria to thrive quickly and rapidly bind the aggregates together. Biomason's biocement cures at ambient temperatures, and it is capable of achieving full strength in approximately 72 hours. This idea is gaining attraction, but we are not sure how much and how quickly cement can be produced this way to fulfill the global cement demand. Cement is undoubtedly the lifeblood of urbanization. It has enabled people to coexist in towering, expansive structures. We walk on paved, clean walkways. Rainwater does not enter our home, and our factories can function day and night. Indeed, without this, our civilization might remain primitive. Our schools, hospitals, and buildings manifest how far the cavemen have come. However, the destiny is still far away, and the only way is to keep finding new solutions for a better future. Hope you enjoyed this video. With what material would you prefer to build your dream house or any building? Let us know in the comments section. We appreciate it if you leave a like and subscribe to this channel. You can find our best videos here. See you next time.